Because I'm happy. Something, 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 something. And I'm happy. No. All right, kind people. Let's go ahead and all right, kind people. Let's go ahead and get started. We're working our way through chapter 3. Uh, Yes, before I get here, let me go back 1 second. A little bit of a review. Oh, wrong document. All right, so last time we looked at measures of central tendency, mean, mode, median, and then we looked at measures of spread or variation. That is range and deviation and your standard deviation. And so a quick reminder, where am I looking for? Right here. So if you have some numbers right here, the first step in working towards finding the standard deviation, your first step is to simply find the average of those numbers. Yeah? After you found the average of those numbers, you find the variations. But we quickly realize that there is a problem with finding the average variation. Yes? If we add up all of these numbers, the answer is always going to be 0, right? And it doesn't make sense that a measure of spread always says all the numbers are exactly the same. Because remember, if you have 0 variation, 0 spread, it means all the numbers in the data set are the same. Yes? It makes sense. So we had to endeavor to get rid of the minus sign. And the way mathematicians chose to get rid of the minus sign is by raising everything to the second power, right? When you raise something to the second power, your negatives cancel out. And so that gives us this column right here. And then we found the average. So we added up all of these numbers and divided by the number of numbers. And that gives us right here something called the variance. Question there. Once you have the variance and you take the square root of the variance, that gives us something called the standard deviation. Questions there? Oh, forget. Set the timer for 20 minutes.
I've set a timer for.
So right here, that is our deviation right here. And then we learned that there are actually two formulas for finding the variance, the variance and the standard deviation. One is called the population variance, and we use the Greek letter sigma squared. Again, that squared just to remind us that we squared all the values before we took the average, yes? And again, add up all the deviations, square them, and find all the deviations, square them, add them up, and then divide by the number of values, yeah? And then we had the sample standard deviation, and in your sample standard deviation, there's one huge change, one key change, and that is we're dividing by n minus 1. Yeah? The basic idea was we knew x bar is incorrect because x bar is the sample mean, right? And because that's incorrect, we're trying to make a small correction right here in our variance calculation to make the number closer to the correct value. Questions there? By the way, it's not random. They actually did, there's math behind why it's n minus 1. We just don't tell you because you need to, you guys ever done, anybody done calculus in the house? Anybody done calculus in the house? Yeah, okay, well, yeah. So, and then if you take the square root, you go from a variance down to your standard deviation. We use S for the sample standard deviation, lowercase s, and we use sigma for the population standard deviation. Yeah? Remember, I showed you this on excuse me, on salt. Salt, the sample standard deviation is always a little bit larger because I'm dividing by n minus 1. That's the only difference in the two formulas, yes? Because of that right here, your sample standard deviation is always a little bit larger. we're allowing for more error in the sample standard deviation. Questions there? You'll be tested on this in the class. So questions. That's right. There you go. Questions. All right. So so there is a standard right here, something called an extreme value or an outlier. A value that's more than 2.5 standard deviations away from the mean is considered to be an extreme value or an outlier. And so if I have a distribution where the mean is 35 and the standard deviation is 4, I can ask the question, is the number 44 an extreme value? Is it an outlier? The first thing you have to just determine, is 44 larger than 35 or is it less than 35? It is larger than 35, yes? And so it means I am looking above 35. Where is mine? So if I had my number line right here, the mean right here is 35 right here. And the question is the number 44 an outlier? In other words, is this something that's unlikely to happen in this data set? It could, but is it something that's unlikely to happen in this data set? And what happens is we have to go 2.5 standard deviations above the mean. So what is 4 multiplied by 2.5? Anybody knows? 25. A quarter is 4 quarters is all, yeah? Yes, that's gonna be 10. And so 35 plus 10, that gives us the cutoff value. What's that cutoff value? 45. And so if a number is larger than 45, it is said to be extreme, an outlier. If it's less than 45, then it is not. So is the number 44, if I got number 44, will that be considered to be an extreme value? And the answer is no, it is not, because it does not go past the cutoff value. Questions there? For the same data set, if I have x equaling 21, is this an extreme value? So what we would do right here is we would first ask ourselves, is 21 above or below the mean? And it is. And so this time we need to subtract. And so we will have to go 35 minus 10 to get the lower cutoff value. 35 minus 10 is 25. So my cutoff value around here is 25. Question, is 21 inside here, meaning it's not extreme, or is it over here, meaning it's an extreme value? 21 is on this side of the bar, and so therefore it is that will be an extreme value for this system. All right? Question there. So if I was giving a test, say for example, out of 50, and I know the average score for my test was 35, and then a score of 0.25, right? And I wanted to do some investigations, right? It may not necessarily mean just take random numbers, but I would first just look at the outlier numbers, right? Somebody got 21, somebody got 48 on the test. I might look at those tests first, right? So I'm trying to analyze, see what happened on the test, yes? Because that can give us insight. Look, this person got all of these questions wrong. The questions they got wrong were the questions that we did first. So it may be they forgot that stuff or they didn't study, right? Oh, this person got all of these questions right that no one else got right. So, why is that? Maybe that person has some background knowledge. Maybe they have taken this class before and they know that that's why they're doing better. So that means I have to go back and look at my teaching to figure out how I can teach this stuff so everyone else can make the grade higher. Yeah, and so I can learn from those extreme values. Questions there? All right. Again, here is this time the a calculation of a sample standard deviation. This time right here, these numbers are not the full data set. It is just a sample. And so what we're going to do right here is to use this formula. First, compute the average. And so I will add all the scores up and divide by n. Notice right here, we're using the same average value. We're going to divide by n minus 1, yes? It is only in the variance / standard deviation calculation that we divide by n minus 1. Yes? So I add up the numbers, divide by 5. My average is 5.4. And then I have to go ahead and find all the deviations and square them. Subtract the mean, square, subtract the mean, square, subtract the mean, square. And again, I'm going to divide by 4. Even though there are 5 numbers in the set, I'm going to divide by 4 because the formula calls for n minus 1. Yes? When I get this number, what is this number called? Is it called a deviation? Is it called a standard deviation? Or is it called a variance? All those who didn't answer, what's it called? It is called the variance. The variance is denoted by the square symbol right here. So this right here is my variance. And then when I take the square root of this, what will I then have? After I take the square root, I will have the standard deviation. Again, notice we're not calling it the average deviation because it is not. The average deviation is always zero. It's always 0, yes? And our standard deviation right here is 2.88. Questions there? So on average, scores are either 2.88 above the mean or 2.88 below the mean. Well, I guess inspired by standard deviation numbers anyways. Any questions there? If I use the same data set, the population standard deviation, the only difference is instead of dividing by 5, instead of dividing by 4, I divide by 5. And so because of that, the answer I'm going to get is going to be slightly smaller. The population standard deviation is always smaller than the sample standard deviation. Questions there? The other one was 2.88. This is 2.58. The entirety of this difference is this 5 right here. It doesn't have a minus 1 next to it. Questions there? Questions there? Okay, not hearing voice now. All right, cool. All right, the last thing right here is the coefficient of variance, or variation, sorry. The coefficient is simply a percentage. It is your standard deviation divided by the average times 100, or the standard deviation divided by the mean times 100. The coefficient of variance right here is a way of scaling your standard deviations so you can compare them. If I have 2 sets, one, for example, with the average. Well, let's say, for example, I have ACT and SAT scores. They don't have the same average, yes? I cannot compare their standard deviations. The standard deviation for the SAT score is like, I think it's like 225, somewhere around there, standard deviation. While for the ACT, the standard deviation for the ACT is like 4 points or something like that, right? Because the ACT only goes up to what, 35, I think, right? Standard, the thing goes up to 800. Well, if you're doing just the math portion, I can't compare the two standard deviations. But if I change both of them into percentages, then I can compare them. Yes, and that's what the coefficient of variation does. It is standard deviation divided by the mean. Questions there? It's the same formula. Just using the different letters because one is for sample and the other is for your population. Questions there? All right, so that's the end of 3.2. Example, I explained this already. And so that's the end of 3.2. We're going to get started on 3.3 and we'll stop near the end of the class. Where is my 3.3 when I need it? All right, so 3.3 is the continuation of measures of spread, measures of variation. And so let's look at what we have right here. First thing we start with is something called percentile. Anybody knows what a percentile is? If I say your height is in the 90th percentile, what am I trying to say? Yes, I am saying that I am very tall, but more specifically, what am I trying to say? If, for example, you are in the 90th percentile, that means from the entire population, you are taller than 90% of individuals. Okay. If on the SAT you scored in the 95th percentile on the SAT, out of all the people who took the SAT that year, only 5% of people did better than you. You did better than 95% of the people who took that test. Yes? Yes? That means you did pretty good, right? If you're in the 99th percentile, right, only a few individuals actually did better than you. Yes? Yes? There really isn't the 100th percentile, but it means that you're the best, right? It's just yeah. Yeah. What about the 50th percentile? The 50th percentile means you are exactly halfway. Half of students did better than you, and half of students did less than you. Yes? Haven't we come across that? Find the middle number in a data set before? What's that called? If I ask you to find the middle number in a data set, what am I asking you to do? Find the median, yes? It turns out that the 50th percentile and the median are the same thing. Okay. Questions there? All right. When I tell you that the median is the 85th percent is the median grade, I explain all of this right here. So the key point right here is that the median is an example of a percentile. It is the 50th percentile. I.e., if I'm at the median, half the scores are below me, half the scores are above me. Percentiles range from 1 to 99. The percentile tells you the percent of data that is at or below it. So again, if you scored on this next upcoming test, if you're in the 25th percentile, does that mean you did well on that test? I have a test coming. Test number 1. Let's say you got the test back. I gave you a grade and I say, hey, just so that you know, you are in the 25th percentile. Did you do well or did you do badly on that test? The answer is it depends. So let's say your score was 91 on the test. You got 91 on that test, and you're still in the 25th percentile. Did you do badly? The answer is both yes and no, right? The answer is yes, because the standards of university and A is a good score, yeah? But the answer is no, because you didn't maximize your grade. Other people were able to score higher than you, right? And so maybe you could have done a little bit more studying to get a higher grade, because it was very possible to get a much higher grade on that test. Yes? The percentile allows you to measure your progress against other people, as opposed to your average, which measures your progress against the university standard. All right? Questions there? So percentiles right here can be thought of in two ways. If I'm at the 25th percentile, it means I did better than only 25% of students. But it also means 75% of the class is better than me. Yes? And so percentiles are given in one of two ways. Normally we say at the P percentile, but you also have the reverse. If you subtract from 100, that gives us the number of the values that are above our score. All right. So the P percentile, this might be the 19th percentile. Is this right here? 19% is below. 81% is above. Yes. P percent, and then 100 minus P percent is above. Questions there on percentile? Because most people have no idea what a percentile is. But generally for government exams, that's how they give the scores, because they can't tell you what other people's scores are, right? They can't tell you, hey, these, and so they give them as percentiles instead, so you can kind of know how you're doing against the population. We did this already, 60th percentile, 60 score below, 40 above. Any questions here? Okay, cool. There are 3 special percentiles. But come on, hurry. The first percentile that's important is something called the first quartile. Quartile sounds like quarter, correct? Yes. The first quartile means I am at the 25th percentile. That's not where you want to be. Yes. Yes. It means literally that only 25% of people scored below you. The first quartile is denoted by Q1, not P1. Any racing fans in the house? P1? No, no racing fans in the house. And Q1, like so. The second important one right here is if I move up another 25%, that takes me to the second quartile or Q2. Q2 means that there is 50% of the data below and 50% of the data above. Is there another name for Q2? It is also known as the median of the data set. That's right. Q2 is always the same as the median for your data set. And can you guess what the last quartile is going to be? The third quartile. That's right. Is there going to be a fourth quartile? Because that's 100%, right? Right. And so last one right here. So you have your median Q2, and then you have your last one right here, your third quartile, Q3. Normally you want to be above the third quartile. It means that only 25% of students did better than you. You did better than 75% of the class. Questions there about my quartiles? If you recall last time when I pulled up what they call that thing again, SALT, that's some of the calculations that they did for us. But before I move on to SALT right here, notice right here that there aren't 3 numbers down here. How many numbers are down here? 5, yes? These 5 numbers are called a 5-number summary. The 5-number summary are your 3 quartiles and the lowest and the highest value. Generally speaking, any data set can be explained with these 5 numbers. If I give you these 5 numbers, that gives you a lot of insight into the data set. What's the lowest and the highest scores? You can literally find the range. If I did that right here, you have the median, so you have the center of the data, so you have a measure for central tendency, and they have Q1 and Q2 and Q3, and that can be shown that Q1 and Q3 can give you an idea of the range or how spread out the data is, right? So these 5 numbers can give you a lot of information about a data set. Questions there? All right, cool. Yeah, we talked about this already. Divide them into fourths, first, second, third, and fourth quartiles. All right, so on to computing quartiles. It turns out that finding quartiles are actually pretty easy. Whenever they ask you to find your quartiles, the first thing that you need to do is to simply find the median. Because the median is going to be Q2, correct? Or trying to find the 3 quartiles. So the first thing to do is you find the median. Yes? After you find the median, somebody remind me, how do you find the median again? Oh, right time. Somebody remind me how you find the median again? Somebody remind me how you find the median again? Put them in order of size. And then? If it's even, you take the 2 middle numbers and you find the average. And if it's odd, you just take the middle value. Yes? Well, guess what? To find Q1, you simply find the median of the lower half of the data. And then to find Q3, you find the median of the upper half of the data. All right? So you're just going to find the median 3 times. Find the median for the full data set. Take the lower half of the data set and find its median, and then take the higher and then find that median, and that will give you your Q1, Q2, and Q3. Questions there? So a classic example, I have 13 numbers right here, I believe. And what happens is I'm going to put them in order of size. Oh, don't make me tap each time. I'm sorry. I apologize. What did I ever do to deserve this? All right, so you tap each number like so. Now they're in order of size. And then you find the middle value. Going to be the median. It's going to be 69. That's the number in between. Yes? And now that I find the median for the entire, I look at these numbers only, 61 through 68, and I find the median of those values. This is 63, correct? That's going to be Q1. And then over here again, I'm skipping the median, 69 to 79. I take the middle value of those, and that's going to be Q3. Okay? So you just find the median 3 times. Question there. Comments, queries, concerns. So your first quartile is 63, and then your third quartile is 76. Oh, sorry. Any questions there? We're going to stop right here. Any questions there? All right. So what I want for you to do is to go into Canvas. How you go to Canvas again? I don't remember. When you go into Canvas, go into assignments. Are we in January? Everybody looked outside? Because my plans at home are getting confused. The poor things. It is so hot right now. Wrong class. That's what the problem is. So right here. So you want to go into assignments, and you want to even sort your assignment by groups, and then you want to go to the group that's in your in-class assignments, which is right here in class work. How am I doing this? Right, and what we're going to work on today right here is calculating the population standard deviation. That's what we're going to be working on right now. I asked 5 students how many pairs of shoes they owned. These are the numbers I got right here. And then basically we want to go ahead and find the variance and find the standard deviation. Question. Are we finding the population variance and standard deviation, or are we finding a sample standard deviation? How do we know that it is a sample? Because I have more than 5 students, right? Yes. And so we're calculating a sample right here. All right, go ahead. That's what we're working on today. As soon as you're done, actually I'll take attendance, and then as soon as you're done, turn it in. Let me see, and then we can have a nice day.